Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Harodi, the Campus Principal. I am back again with another video. In this video, I want us to talk about quality control. As we have learned about the calibration in the previous video, that it is done to determine the accuracy of the machine, and then we use substances of known value called a calibrator. So with quality control, it's every business or lab's goal to make sure that whatever the results that they send out, it is proper results, and that those results are accurate and precise, and that they represent the concentration of what is happening in the patient's body. And this is usually obtained by running quality control samples, and then those samples we will run them together with patients. What are these quality control samples? So quality control samples, we usually just call them QCs. They are a substance that contains a range of known values. So we know that that sample for that specific analyte, it needs to read between the certain value to another value, and as well they represent a group of patients, so they can represent low, normal, and high patients. What do I mean about that? For example, we find that in most cases, let's take sodium as an example. You'll find that it will have 3 levels of QCs, and then level 1, which will represent low values, level 2 will represent normal values, and then level 3 will usually represent higher values. But it is not like always every time that it's like that. Sometimes you can find that for the analyze that have 2 levels, you find that level 2 it's the low and level 1 is the high. So it will just depend. So this was just an example. So like I said, we will run these samples together with the patient specimens or the patient samples, and the same way we treat the quality control sample is the same way that we'll need to treat the patient sample, so that at the end of the day we will know that whatever result that we are sending out, it is accurate and precise as much as possible. So, and again, when we run those samples, so daily identification of QC deviations, it has to be done so that we can see how far is our QC deviating from the range. So that's why every time when you run these quality controls samples, you need to check their values. Is it still within the range, or if is it outside the range, so that when it's outside the range, you can be able to try to troubleshoot it and to check what is the cause of that troubleshoot, and then before you can run your patients, so that you make sure that by the time you send out the patient results, you know that your QC is in and everything else it is well. But what happens is that we also have the LJ graphs. So these LJ graphs, basically it is a tool that we usually use in the laboratory to monitor laboratory QCs, the QCs that we run, and then the LJs together with the Westgard rules. So basically they are used to determine trends, bias, shifts, etc. on the graph. So what we usually do, like I said, on daily basis, we do check the daily deviations of the QCs, and then some labs they can also do weekly, twice week, every second week, or every month, whereby they do LJ reviews to check for those trends, bias, shifts, and so on, and then try to troubleshoot that. So on that note, now we know that we use LJ graph as a tool, but how do we get that LJ graph? Okay, so for us to be able to draw an LJ graph, or to generate an LJ graph, what we need to have the mean and the standard deviation. Is very important for us to be able to have it. So what usually happens is that in the laboratory, we will receive QC samples either from the supplier that of the machine that we are using, or from the third party, whereby we will get a QC sample for samples for specific analyte. In these days, it does happen that most of the time we find that whatever that when we get that sample, we also get a package insert, and then on the package insert there will be values that we will need, like the mean, the SD, then or it can be the mean, and then they'll give us all the points, the 1SD, the 2SD, and the 3SD points. But then now we need to learn in this case that we have to know from the beginning how we can get that for those tests whereby probably we are not given that, so because it can happen. So what happens is that when the laboratory receives that QC sample, if they don't have a mean and they don't have an XD, what they can do, they can run that sample about 20 to 30 times depending on the lab's protocol. And then after running that QC probably for 20 days or 20 times, depending on how they do it, and then they're going to have 20 values. And once they have the 20 values, now they will use those values to calculate the mean and the standard deviation. I'll show you now shortly how to calculate the mean and the standard deviation, but please know that in my example I'm not going to use 20 values or 20 results, so I'm just going to use about 5, but the principle is the same, and the formula is the same. You just follow it as it is. It's just that we will divide by either 5 instead of 20. So what is the formula to calculate the mean? So that is the symbol of the mean. So it is the sum of values divided by the number of values. So let me give you the numbers that I have. Here's an example. Let's say we got 160. So let's say these are the values that we got after we ran our QC sample or the patient sample. Other labs, they use patient samples. So what we will do now, we say is the sum. So when you talk about the sum, now it means we are talking about addition. So it means you're going to say 160 plus 165 plus 163 plus 167 plus 164. Divide by n, represent the number of values. So how many are there? You can count 1, 2, 3, 4, 5. So it means we're going to sort of divide by 5. And then we're going to punch that into the calculator, and we find that now our mean is equals to 163,8. So once we have our mean, now we can calculate the standard deviation. So we can just write the mean there so that we can remember it's 163,8. And then the standard deviation, how do we calculate the standard deviation? So the formula of the standard deviation is the SD is equals to the sum of the root of the number of the value, which is xn, minus the mean squared divided by n minus 1. Then what you do now, you're going to substitute. So it means it's going to be xn, the first one is 160, so we're going to have 160 minus our mean is 163,8, and they say this it is squared plus, because we said the sum, right? So it's 165 minus 163.8 squared plus 163 minus 163.8 squared plus, and so on. So it means you're going to add all 5 of them. And then you say it's the root, divide by n. So we said the number of these values, they are 5. So it's going to be 5 minus 1. And then after you have added all of them, the answer that you're going to get from there is going to be 2.6 when we round it off. So it means now your mean is 163,8 and your XD is 2.6. So now once you have your mean and your SD, Now you can be able to calculate your 1SD, 2SD, and the 3SD range, and then you can be able to plot the graph. So now let's calculate the SD ranges. So plus 1 SD and the minus 1 SD. I'm going to do them like this. So how do we calculate the plus 1 SD? Basically, the plus 1 SD is the mean plus the SD. So in this case, it's going to be 163,8 plus 2.6, which is equals to 166,4. So that's our plus 1 SD. And then our plus 2 SD is going to be your mean plus the SD multiplied by the 2, because we need the 2 SD, which is going to be the mean plus the SD, which is 2.6 multiplied by 2, and this gives us 169. Then our plus 3 SD, which is the same, going to say it's the mean plus the SD multiplied by 3. Then it's 163.8 plus 2.6 multiplied by 3, and this gives us 171.6. Then when we come to this side, it becomes the mean minus the SD, which is 163.8 minus 2.6. Then our minus 1 SD is equals to 161.2. Then our minus 2 SD is going to be the mean minus the SD multiplied by 2, which is 163.8 minus 2.6 multiplied by 2. And our value for our minus 2 SD is 158.6. Then we're going to do the same for the 3 SD. So for the minuses, we subtract, and for the pluses, we add. So it's SD 3, then it's 163.8 minus 2.6 multiplied by 3, and then we have 156. So now once we have our values or all our SDs now, in this case now it means we have everything that we need to be able to plot our LJ graph, and then we can plot the graph. So let's plot the graph. So what the graph constitutes of, it constitutes of the mean minus 1 SD minus 2 SD and minus 3 SD. Then we're going to plus 1 SD plus 2 SD and plus 3 SD. So in our case now we do have values. So our mean is 163.8. Then our minus 1 SD is 161.2. Then 158.6. Then the number of this one is going to be 156. Then with the plus 1 SD, it's going to be 166.4. Then the plus 2 is 169. And then the plus 3 is 171.6. So this is how the graph looks like. So usually the mean will have a solid line. And then these are your voila. So this is your SD graph. So this is how you will do an SD graph. But now I gave you an example whereby you have to do 20 run your sample 20 times, either the patient sample or the QC sample, and then you will draw the LJ graph. So drawing the LJ graph, it will be the same for all of them. But now I need to also show you the 2 instances that you can find. so that you will know in whatever cases when you get the situation, you can be able to tackle it. So let's say now in this case, then your supplier gives you the QC and it also supplies you with the mean and the range, but they don't give you the SD. And remember, you do need the SD to be able to determine your 1 SD and your 2 SD, depending on what range it is. So let's say now your supplier gave you the mean is 20. And they gave you the range 17.6 to 22.4. So now you need to be able to get the SD so that you can put them in your graph. So what you need to do now, what is very important, is that you need to determine that the release range that they've given you, is it a 2 SD range or a 3 SD range? So in the case of our example, we're gonna take it is a 2 SD range. So it means if this is a 2 SD range, so this it means it's your minus 2 SD, and then this one is your plus 2 SD, your upper value. So this is your lower value and the upper value. So now, but to draw a graph, to have an LJ graph, we also need the 1 SD, right? And we don't know what is the 1 SD value in this case. So now it means we need to determine the SD, and then from the SD we can be able to get the 1 SD range. So what we will do now to be able to get the formula that you can use is that to get the SD, the standard deviation, it's going to be standard deviation, because we said it's a 2 SD range, or you can say the upper value minus the mean, and then divide by 2. The upper value now it's 22.4 minus 20 divided by 2, and then this give you a 1.2 value. So this 1.2 is your SD. So this question usually you will find it especially also in an exam, whereby they give you the range and then they tell you that calculate the SD. Then this is the what you're gonna follow. So let's have if let's say this was a 3 SD range, it means now you are going to divide by 3. So basically that's where the difference is. So if they said this is a 3 SD range, you're gonna take the upper value, you're gonna minus the mean and divide by 3, and then definitely you'll be able to get your SD. And then from this SD, you can be able to, for a 2 SD means you just need to get a plus minus 1 SD. For a 3 SD range, then it means you'll have to get the plus minus 1 and the plus minus 2 SD, and then you can be able to draw the graph. So that's one instance. And then the last one that I want us to do is that sometimes you can be able to find a question, or either you find a packaging set whereby you are only given the range, no mean, no SD, nothing, but it's just the range. So if they're the range, they say it's 17.6 to 22.4, and then they tell you now here calculate the SD and also calculate the mean that it is used in this case. So what you are going to do then now, you can start by calculating the SD. So which the formula will be SD, it is the upper value minus the lower value, and then divided by. So the divided value as well, it will also depend whether is this a 2 SD range or is it a 3 SD range. So this one we're gonna use it as the 2 SD range. So if it's a 2 SD range, we're going to divide by 4, because from your LJ graph, if you can see, let's say if it's a 2 SD range, so it means this is your minus 1 SD minus 2 SD. It's the mean, the plus 1 SD, the plus 2 SD. So you have 1, 2, 3, 4. So it's divided into 4. So that is why you're gonna divide by 4. And then if it's a 3 SD range, you'll see your graph is divided into 6. So that's why you will have to divide by 6 if it's a 3 SD range. So with this one, what is important is to make sure that you get clarity on which SD it is used. But in an exam, if you are not told whether it's a 2 SD or a 3 SD range, you can rather use the 3 SD range and just assume that it's a 3 SD range. So now, so the upper value is 22.4 minus 17.6, which is divided by 4. And then this gives us 1.2. So this is our SD now. Then after we got our SD, now we need to calculate the mean because we were not given the mean as well. So to calculate the mean, it's going to be, let me use this symbol. So it's going to be your lower value plus SD times 2 because it is a 2 SD range. So your lower value is 17.6 plus the SD that you got here, it's 1.2 multiplied by 2. And when you punch this into a calculator, you get the value of 20. So if it was a 3 SD range, you were going to multiply that by the SD by 3 to be able to get there. So basically, that's what it is. If you got the range, this is how you're going to determine your mean and your SD. And then if you only have the mean and the range, you can be able to determine the SD from there. So basically, this is what I wanted to share with you in this video with regards to quality control. We will continue more with the Westcott rules and the LJ reviews in the videos that are going to follow. So stay tuned. Thank you so much for joining me. If you have any questions or anything that you need to add, you can put them there in the comment section. I'll be happy to interact with you. And then from me to you, up until next time, bye.